Welcome to episode 29, Application Hosting Options in Azure, where we explore how to choose the right home for your applications in the cloud. Azure offers many ways to run software, but good design begins with the application itself, its requirements, users, and pace of change. A web app serving millions of customers behaves differently from a background service or an internal dashboard. By starting with what the app needs rather than what the platform offers, you build fit-for-purpose solutions. Each Azure hosting service aligns to a distinct balance of control, scale, and simplicity. Understanding these patterns helps teams avoid both under-engineering and overcomplication, ensuring that resources match business outcomes rather than personal preference or habit. Azure App Service remains one of the most popular options for hosting web applications and APIs. It abstracts service completely, letting developers deploy code using frameworks like .NET, Java, Python, or Node.js without managing the operating system. App Service provides built-in load balancing, automatic scaling, and integration with authentication and monitoring tools. Imagine deploying an API and having SSL, patching, and scaling handled automatically. This platform fits organizations seeking predictable runtime environments and quick deployment pipelines. Common use cases include customer portals, mobile backends, and business APIs that demand steady availability without infrastructure overhead. It's the practical middle ground between virtual machines and full serverless computing. Azure Container Apps simplify running microservices without needing to manage Kubernetes directly. Each containerized component runs in its own environment, scaling independently based on demand or custom events. Container apps integrate naturally with Dapper for service discovery, state management, and pub/sub messaging, reducing boilerplate for distributed systems. Picture a retail system where inventory, checkout, and notifications each live as separate microservices that scale independently. With container apps, you define containers and scaling rules, and Azure handles orchestration behind the scenes. It provides the flexibility of containers with the operational ease of a managed service, perfect for teams adopting cloud-native practices without deep Kubernetes expertise. Azure Kubernetes Service, or AKS, serves teams that need maximum orchestration control. It runs full Kubernetes clusters where you define nodes, networking, and deployment strategies. This suits complex microservice environments, hybrid scenarios, or cases where workloads must mimic on-premises standards. With AKS, you can implement custom controllers, network policies, and service meshes for granular control. However, this freedom brings responsibility for upgrades, node pools, and security posture. It shines when scale, customization, or multi-cluster governance are priorities. For example, a global financial application might rely on AKS for its flexibility to meet strict compliance and high availability demands across regions. Serverless functions offer a radically different model, code that runs only when triggered. Azure functions handle short-lived, event-driven workloads such as processing form submissions, reacting to file uploads, or connecting disparate systems. Developers focus purely on logic. Azure provisions and scales the infrastructure in milliseconds. Pricing reflects usage, not uptime, making it ideal for bursty or intermittent workloads. Imagine a service that resizes images whenever a customer uploads a photo. It may execute thousands of times per hour or none at all, and costs align accordingly. The trade-off is limited runtime duration and less environmental control, but agility and efficiency make serverless a valuable piece of the hosting puzzle. Azure Static Web Apps serve the opposite end of the spectrum, front-end applications that require no server logic. They host static files such as HTML, CSS, and JavaScript directly from repositories, automatically deploying from GitHub or Azure DevOps. This service excels for single-page applications and front-ends that consume APIs elsewhere. It integrates global content delivery networks, authentication, and staging environments without configuration. For example, a marketing site or documentation portal can deploy globally in minutes and scale to millions of views effortlessly. By removing server management entirely, static web apps turn simple code bases into resilient, distributed experiences with minimal overhead. API management acts as the gateway and control plane for published APIs, providing a single front door for consumers. It enforces authentication, rate limits, caching, and transformation policies consistently across back-end services. This matters because as systems grow, APIs multiply and need governance. With API management, you can protect legacy services behind modern interfaces, expose analytics on usage, and standardize documentation for developers. Picture an enterprise exposing dozens of internal APIs. A gateway ensures uniform authentication and throttling without rewriting code. It's the connective tissue between development and consumption, turning distributed backends into a coherent, managed platform. Messaging and eventing services glue applications together without tight coupling. Azure Service Bus handles ordered, reliable message delivery for business processes requiring transactional consistency, while Event Grid distributes lightweight notifications for real-time reaction. These patterns decouple producers and consumers, letting systems evolve independently. For instance, a billing system can emit messages that accounting or analytics systems consume at their own pace. This loose coupling improves scalability and resilience. By integrating these services with compute hosts, whether containers, functions, or app service, you build reactive architectures that remain stable even under high load or partial failure. Data backends complete the application landscape. Azure offers SQL Database for relational data, Cosmos DB for globally distributed NoSQL workloads, and storage accounts for blobs, files, and queues. The choice depends on data structure, latency needs, and scale expectations. Many applications combine several backends, for example, SQL for transactions and storage for unstructured content. Integrating these data services with appropriate compute hosts forms the backbone of reliable cloud applications. Ensuring proximity within the same region or virtual network reduces latency and supports compliance. Selecting the right storage pattern is as vital to performance as the compute layer itself. Networking links all these components securely. Private endpoints connect applications to data services without traversing the public internet, reducing exposure. Ingress controllers and application gateways manage traffic from users to the right service instance, often integrating with web application firewalls for protection. For example, a containerized API behind a gateway might route traffic through private links to a database while blocking direct internet access. Proper network planning prevents accidental bottlenecks or open exposure. In Azure, security and connectivity planning go hand in hand, turning app topologies into resilient and compliant ecosystems. DevOps pipelines and deployment slots enable continuous delivery without downtime. Azure DevOps and GitHub Actions integrate directly with app service, functions, and container apps to automate testing, building, and deployment. Deployment slots allow staging new versions alongside production, then swapping them instantly once verified. This prevents broken updates from reaching users. Automated pipelines also enforce quality gates and version control, improving collaboration between developers and operations. The result is smoother releases and fewer late-night rollbacks. Continuous integration and deployment turn hosting services into living systems that evolve safely and predictably. Observability closes the feedback loop through application insights and related tools. Application Insights tracks requests, dependencies, exceptions, and performance metrics across distributed services. It helps teams see how an application behaves under real conditions. For example, tracing a failed user transaction might reveal slow database queries or external API latency. Combining telemetry from compute, data, and networking services gives a unified operational picture. Observability transforms troubleshooting into measurement rather than guesswork. It's not optional. It's the only way to maintain reliability as systems become more modular and dynamic. Cost, scale, and reliability always trade against one another across hosting models. App service and container apps reduce management overhead but have fixed cost baselines. Functions and static web apps scale cheaply with unpredictable workloads. AKS offers deep control but demands higher expertise and operational cost. The decision rests on business rhythm. Stable, steady-state systems justify reserved capacity, while variable workloads favor elasticity. Reliability often rises with cost, but not always with complexity. The best architectures mix models deliberately, letting each layer operate in its most efficient zone. Balance, not uniformity, defines sustainable cloud design. Choosing a hosting option in Azure becomes simpler when guided by patterns. Start from application characteristics. Is it user-facing, data-heavy, event-driven, or background processing? Map those traits to the models: app service for managed web workloads, container apps or AKS for distributed systems, functions for reactive tasks, and static web apps for front ends. Add API management, messaging, and data services to complete the ecosystem. Then wrap it with DevOps and observability for full lifecycle control. The strength of Azure lies in flexibility. By matching the right service to each component, you achieve a design that scales gracefully and stays aligned with both technical and business goals. Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.